when I have log to the base x times y. Two numbers, two functions, I'm not gonna care. Log to the same base x times y is going to be log to the first part plus log to the second part. Not that much hard. Multiplication is going to be addition between two logs. The first log for x, the second log for y. If I have division, x divided by y is going to be the top minus the bottom. If you flip it, it's going to be wrong. The top minus the bottom, okay? The same base, okay? If I have log to a number with exponents, I'm going to move the exponents in front of the log. Is that hard? That's what we're gonna do. If you look to the next example, it says log 2xy. Log 2xy. I'm gonna ask you, how much the base? 10. No, there's no 1. You can put 1, it's fine. But when there is no base, remember the common logs? The common logs, 10. That's why they choose it as a common log. If there is no number, that means it's 10. Okay? Now, 2xy, what's the operation between 2 and x? Multiply. What's the operation between x and y? Multiply. That means this one I can write it down as a log to the 2 plus log to the x plus log to the y. That's it. I just use the same rule here. Every time I have multiplication, I'm gonna convert it to addition. But the base here is the same base, which is 10. Is that hard? What about the next one? Then the 3a. By the way, these rules, it's work on the same when we have len. When we have len, you can use the same rule. Instead of log, you're gonna put len. So len x, len y. Is that okay? So now with the next example, we have len 3 and a plus b. Right? We don't have to distribute and look what's gonna happen next. No. Then what's the operation between 3 and the parentheses? Multiply. So can I say it's len to the 3 plus len to the a plus b? Is that okay? Yes, we just using this is number 3. I skipped number 2. Let's check number 2. What's the difference between 2 and 1? Oh, the base. I'm not gonna do it.
Same thing, right?
It's the same thing, just extra base. Instead of base 10, we have base 2. So give me base 2 here, base 2 here, and base 2 here. That's it. That's why I thought it's the same one. Number 4. We have log to the base 7 z divided by 49. How are we going to solve it? Going to be log to the base 7, the top always, minus log to the base 7 to the 49. Now think about that, because that's what you're gonna get when you're doing the homework. Can I simplify it more?
Yes. Factor the 7 and the 7 and the 49 and the 7 or no?
Oh, wait. So we're talking about this part or this one?
Yes.
No. You are on the right guess. You can't do anything here because it's a variable.
Oh, okay.
So this part is still the same. But what about this one? Always think in a way you can simplify it. So let's check here. This is equal.
I thought it was a 7, but it's a z. Yeah.
No, this is z. Yeah, it's log the base 7, and here is the z minus log to the base 7. Can I write down 49 as a 7 squared? So always think when you see a number, that means there's a way to simplify it if you can. Now check here on this part. Can I move the 2 here? I'm using this. Only on this part, I'm using this rule. If I have exponents, I'm going to shift the exponents where? In the font. Is that okay? Yes or no? It will be log the base 7 to the z minus 7, not 7, 2 log to the base 7 and 7. Now tell me, can we simplify it more? How much the value of log 7 to the base 7?
1.
1. What about the second rule? We have the base similar to this one. So it's going to be 1. That means the result is going to be log the base 7 to the z minus 2. Because 2 times 1 is going to be 2. Is that okay? It's okay.
So you multiply it?
Yeah, because it's multiplication.
Okay. And the log disappears?
Which log? About this one?
Yes. Or it stays in there, but
Remember we have log base, if the base is the same number equal 1. Right? Which rule? The second one or the third one? Number 3. And when you have base similar to the number equal 1. That means the whole value here equal 1. So 2 times 1 is going to be 2. Okay? Can we do the same thing with the next one? Number 15, number 5. Jump in. It's log the base 7 a divided by 14. Come on, this one is easy. You don't know. If it is, there's more than one way to solve it. Not more than one way to solve it, but you can keep simplify it. So now, if I want to use the second rule, it's going to be what?
7 times a minus log 7 times 14.
No, you can't say log 7 times a. Yes, they're gonna, who taught you that? They're gonna blame me. It's log to the base 7 to the a, or log a to the base 7. Okay, that's more professional. Log a to the base 7. Okay, so minus what? Log 14 to the base 7. Okay, that's perfect. Now, can we simplify it more? Always the problem, look to the number, okay?
14, but
The 14 you can write down as a number with exponents. But can I write down as a multiplication between two numbers? By the way, this is the right solution. You can stop until here. But can,
7 times 2.
you can say log 7 times 2. And it's time you can use rule number 1 on it. You get the idea? So I can say here, it's log 7a minus. I'm going to say it's log to the base 7, 2 times 7, right? I can do that. Now, only on this part, it's log the base 7 to the a, only on this part. Here is minus. Can I use rule number 1 only on this part? Can I say it's log to the base 7, 2 plus
7 to the base 7.
Can I do that? So I can say it's log. You see, I put parentheses because the negative sign is going to go for everything inside here.
Log.
So give me log
7 plus 1.
2 plus log base 7 to the 7. Can I do that? Now check what happened here. How was the result here? 1. So log to base 7a minus log 2 to the base 7 plus 1. Now, can I distribute the negative sign? So log base 7 to the 8 minus log base 7 to the 2 minus 1. That's it. You can't simplify it anymore. And biology and chemistry, if you're taking these classes, on the question, they're going to tell you log 2 to the base 7 equals 0 point something. And they're going to tell you this amount, maybe you're going to find it or you want to find it. So they're going to give you the result of this one, how much it's going to be. You're just going to go ahead and plug it. If you're taking advanced chemistry classes, whatever. You get the idea? So you have to simplify it. I'm telling you, the solution sometimes on Alex, they're going to accept only here. But in fact, you have to simplify it until the lowest number. You have to go here, and here's 1. You see, it's easier to work on these numbers. Okay. What about example 6?
Can you subtract that one right there, like the log, like if the a was a number, could you subtract it with a 2?
No, don't do that. Why? That's a good point. It's the same base, but different numbers. You can't say this one is, for example, if we have 2 here, can we say this one, how much is going to be the result? Let's assume that A is 2.
0?
No,
0.
not 0. Why?
Can't be 0.
It can be 0, but why? Because it's minus between 2 log. If you go back to the original, it's a division. So you're saying log to the base 7, which number here? 2 divided by 2, which is 1. How much log to the base 7 to the 1? Maybe 0. Go back to the 0. You get the idea? But the main thing, what I'm telling you, try to simplify it as much as you can. See what we did here? On Alex, maybe they're gonna accept this one as a solution. Maybe, I don't know. If they're telling you simplify it more, you have to keep going down. Is that okay? What about number 6? Number 6 is what?
100
Log 100 divided by x plus y equal what?
100 minus
2 minus
100 minus
1.
x plus y. This part I can't do anything here, right? Because it's x plus y, I can simplify. What about this one? Can I? How you gonna simplify? It's log to the base 10. Can I say 10 to the power 10?
To the power of
10 or 2? Yes, 2, because it's 10 times 10 is going to be 100. So how much that is up? 2. Move the 2 here. X plus y. So give me 2 log to the base 10 to the 10 minus log x plus y. much the amount here? It's 2 times 1. 2 minus log x plus y. Is that okay? Yeah, now. Number 7. The same thing, we have ln x to the power 5. Being equal, we're just gonna move 5 ln x. That's it. How about next one? It's ln e to the power 5, right? By using the second properties, that means you can move the 5 here, which is 5 ln times e, right? Yes or no? What's the meaning of ln? Log the base e, and here's the e. So the whole part here is equal what? Equal 1. That's why it's 5 times 1 equal 5. That's why I'm telling you, every time when you see ln with the e, just write down the 5 right away. You got it? Yes or no? What about next one? Have log the cubic root of x squared equal what?
2/3 times log.
Yes. Because this one is the same thing, log x as the exponents converted to rational is going to be 2/3. Now move the exponents in the front. So it's going to be 2/3 log x. And the base is 10.
Question, how'd you make the X disappear? On that one.
So we have wait.
No, that's the next different question.
Okay, I was like, man,
My fault.
Took me a minute to.
Where's the x? Yeah, I forgot it. I don't know what's the next one. I don't have it. What's the next example? So, 5c/w. 5c/w. 5c/w, right? Okay. Yeah, solve it.
Three times 7 base 3.
So log to the base 3, 5c. Right? Minus what?
Log base 3 double.
And this is multiplication. So it's going to be log to the base 3, 5 plus what? To the z minus log base 3. Okay. We do the same thing with number 11. Same thing. Ah, be careful. With number 11. With number 11, you have to be careful. Log 11 to the AC ID. You can say what? It's log to the AC minus log 5d, right? Next step is going to be log A plus log C. Minus, be careful here. When you put minus and you have multiplication, you can open parentheses. because the negative sign for everything here, which is log 5 plus log b. Then you can distribute the negative sign. This means it's going to be log a plus log c minus log 5 minus log. Okay. Put circle on this one.